Okay, let's continue. Go to question number 6. You are asked to find the exact value of this expression. So this question requires you to know the definition for cos hyperbolic x and sin hyperbolic x. So how do you define cos hyperbolic of x, students? The cos hyperbolic of x is defined as e to the power of x plus e to the power of minus x over 2. But here you are asked to find cos hyperbolic ln 4. So in place of x you are supposed to use ln 4. So put ln 4 here, and again here minus ln 4 divided by 2. We know that e to the power of ln 4 is 4, right? Because this is e to the power of logarithm 4 to the base e, so 4 is going to come as it is. And we can bring this minus as exponent here for number 4. It's going to be ln 4 to the power of minus 1, and 4 to the power of minus 1 is 1 over 4. So e to the power of ln 1 over 4 is 1 over 4. So you are having plus in between, so have it as it is. Then this is divided by 2. And this makes 17 over 4 divided by 2, which actually is 17 over 8. So 17 over 8 can come. And proceeding to the next one, we have sine hyperbolic of ln 0.25. And we need to know that one because it is already expressed here. And we know that 0.25 is 1 over 4. So sine hyperbolic of ln 4 is e to the power of ln of 1 over 4 minus e to the power of negative ln of 1 over 4 over 2, because sine hyperbolic x is e to the power of x minus e to the power of minus x over 2. So in x, I directly used ln of 0.25 or ln of 1 over 4, okay? So we can have this expression. Now the next task is a matter of simplifying this. This is logarithm of 1 over 4 to the base e, so e to the power of logarithm of 1 over 4 to the base e is 1 over 4. And here we can bring this minus up. So as you are taking this negative as exponent, look, for the power of minus 1 is existing before as 1 over 4. Due to the presence of two negative 1 expressions as exponent, you to have positive 1. Hence 4 is going to come for this term. So what you need to have is the following. As you see, 1 over 4 is written as it is directly, and here 4 is used because having extra minus here makes negative 1, which actually is positive 1. So you see 1 over 4 minus 4 over 2 can follow, and from this negative 15 over 8 can come. Just try to simplify this. Now we have determined what cos hyperbolic of ln 4 is, so in place of this we need to use 17 over 8. So here 2 times 17 over 8 is expected. Then here minus 3 times this expression, but sine hyperbolic of ln 0.25 is already calculated, as can be shown here. So negative 15 over 8 is copied and pasted here. So you see the expression is going to be like this. So look, cos hyperbolic of ln 4 is calculated. It is 17 over 8. So 2 times 17 over 8 is going to come. This 2 comes directly from this one. And here minus 3 is again taken. So sine hyperbolic of ln 0.25 is negative 15 over 8 times 3. So this has to be divided by 4. You see, because it has been stated here, it has to be divided by 4. So 2 times 17 makes 34. And here minus 3 minus 15 makes 45. So 34 plus 45 makes 79, and here 8 times 4 makes 32. So this result is going to be 79 over 32. I hope you have understood. Next from this we have the next one. It says, suppose you are given tan hyperbolic of x to be 4 over 5. Then you are asked to find cos hyperbolic of what? The same x. So what you need to do here is you have to know the definition for the tan hyperbolic of x and some identities too, okay? So remember that tan hyperbolic squared x plus sec hyperbolic squared x makes 1. This is proved in our classroom, so actually you can also prove it. We knew what tan hyperbolic of x is. It is a ratio of sine hyperbolic of x and cos hyperbolic of x, and we also knew sec hyperbolic of x. It is 1 over cos hyperbolic of x. So as you are squaring this, you're also squaring 1 over cos hyperbolic of x, so it's going to be 1 over cos hyperbolic squared x. So as you are summing these two and simplifying it, you will finally come to this identity. 1 can come. So from this identity, you can now solve for sec hyperbolic squared x. Just move this one to the right, and then you can have this. Look, 4 over 5 is tan hyperbolic of x, so square it as it has been written here. Sec hyperbolic squared x equals 1 can come. And from this, moving this 4 over 5 to the right, it is going to be 16 over 25. 25 minus 16 over 25 is going to come, which actually is 9 over 25. So now, the value of sec hyperbolic squared x is determined. You see, it's obtained to be 9 over 25. But our intention is to determine what cos hyperbolic of x is. So we need to have a mechanism of, you see, interacting sec hyperbolic x with cos hyperbolic of x. And for that to come, we have to recall the definition for sec hyperbolic of x. As you studied, sec hyperbolic of x is nothing but it is 1 over cos hyperbolic of x. Or you may also define cos hyperbolic of x to be 1 over sec hyperbolic of x. So from this we can obtain the following one. Look, using the identity cos hyperbolic of x is equal to 1 over sec hyperbolic of x, one can obtain that cos hyperbolic squared x is the same as 1 over sec hyperbolic squared x. You see what has been done here? We simply have squared both sides. You see, if you square these two, so long as they are the same, cos hyperbolic squared x can come, as can be shown here. Cos hyperbolic squared x can come. And again, as you are squaring this, 1 over sec hyperbolic squared x can come. The one obtained here is sec hyperbolic squared x. So you can directly now put 9 over 25 in place of, you see, this one. You see, here in the denominator, sec hyperbolic squared x is written. So you can directly copy this and paste here. 9 over 25 is going to come. So what is 1 over 9 over 25? Take the reciprocal, which actually is 25 over 9. Right? So from this, we can obtain that cos hyperbolic squared x is going to be 25 over 9. The reason is, you see here, 1 is supposed to be divided by 9 over 25, because this one is already determined. As you see, sec hyperbolic squared x is 9 over 25. So take the reciprocal, it's going to be 25 over 9. Now look, students, what we obtain here is cos hyperbolic squared x is equal to 25 over 9. Our intention is to find what cos hyperbolic of x is, not cos hyperbolic squared x. So in order to have cos hyperbolic of x from cos hyperbolic squared x, what we need to do is we have to take the plus or minus radical of this expression. But as you know, cos hyperbolic x can't give a negative value, because by definition cos hyperbolic of x is a the power of x plus e the power of minus x over 2. So as you are observing, e the power of x and e the power of minus x, they both are exponential functions, having positive real numbers as what? As a range. So the linear combination of the two can't be negative. Because of this, as you are taking the square root of cos hyperbolic squared x, we must take only the positive output. So as can be shown here, cos hyperbolic of x must be the plus of the square root of 25 over 9, sorry. Because, as I said, everything, if you observe the graph of cosine hyperbolic of x, it was totally drawn, you see, above the x-axis. This shows you that above the x-axis, this shows you that the range is 1 to infinity. Basically, cos hyperbolic of x has a range 1 to infinity. So, having this range, how can we have a negative output for cosine hyperbolic of x? We can't have. Because of this concept, the cosine hyperbolic of x value from the square root must be positive. So, take the positive square root of 25 over 9. So, the positive square root of 25 over 9 makes 5 over 3. Thus, we were asked to determine cos hyperbolic of x, provided that tan hyperbolic of x is given. So using the identity tan hyperbolic squared x plus sec hyperbolic squared x equals 1, we have obtained sec hyperbolic squared x to be 9 over 25, as you see from this one. And finally, using the concept that the range for cosine hyperbolic x is from 1 to infinity, we took the positive You see, square root, and obtain that and finally we obtain that the square root of 25 over 9 is 5 over 3. Hence, cosine hyperbolic x is 5 over 3.